Hey everyone, thank you all for joining us today for another Apache Pinot meetup. So today's topic is operating Apache Pinot at Uber scale. And just some quick lay of the land. First of all, if you like the video, definitely give it a thumbs up on YouTube. And you can also subscribe to the channel if you want to see more upcoming events. And obviously the meetup group as well. If you have any questions during the presentation, feel free to ask them. Some of the questions, if you do have a question directly for Ting, the presenter, we will be doing a Q&A after the presentation. So just put in there like, Ting or something like that, so we know to like refer to him at the end. We'll save it for the Q&A. Or if you want to just wait until the Q&A, you're welcome to ask questions then. There is like I think 5 or 10 second delay on the video. So when we tell you guys, you could just flood the questions in. Also, if you are watching this on demand later and not live, and you do have additional questions for Ting, or you just want to tell him how much you love this presentation, you can reach him at the Apache Pinot Slack. We will put the URL for the Slack in the description of the video, as well in the comments over here as well. So just to give you a little bit of background on Ting, he is a software engineer in Uber's data team. He is a tech lead of the Stream Analytics team, whose mission is to provide fast and reliable real-time insights to Uber products and customers. Ting is a Apache Pinot committer. So let's welcome Ting. Hey, Ting.
Hi, good world. Yeah, I think many of you join us from various time zones. This is a very time. So
interesting. Yeah, I'm curious to know where everyone's from.
Yeah, exactly.
We'll tell people, if you're watching and you're from an interesting time zone, just let us know where you're from. I'm in Philadelphia right now.
Exactly. I'm really honored to be invited by StarTree, this new actually founded company, to give this talk about Apache Incubator Pinot. Of course, I will just call it Apache Pinot. Yeah, as I see, I'm a committer for Apache Pinot for the past year. So probably here I represent a slightly biased view of Apache Pinot, but we do think we want to share how we use it at Uber, and probably also equally important, why we use it in Uber here. All right, so this is the talk I'm going to do here today. I remember I gave it this similar talk about half a year ago, but since this last talk, right, there are so many things happened for Apache Pinot, and a new company, StarTree, was actually announced for supporting Apache Pinot. I think there are also a lot of activity and new features released since then. We at Uber do enjoying a lot of these new kind of features. So that's why in this talk, actually, I added quite some content reflecting the most recent changes we had. All right. Hi, Karen, can you see my slides?
Yes, we can see your slides.
Okay. Yeah. So let me get started, right? So today's topic is mainly about how Apache Pinot is used by Uber for its data analytics application. So I don't want to repeat what Karen has said about myself. So I am an engineer at Uber, Apache Pinot committer. So for today's talk, right? So I will first explain how Apache Pinot fit in Uber's data ecosystem, and after that, I will explain a few concrete use cases of Pinot here, and then I will probably spend about 20 minutes to do a high-level, gentle introduction of Apache Pinot. And after that, I will basically follow up with some I call it advanced topics or advanced feature, but mainly about how here at Uber we basically make Pinot work for our larger data ecosystem. Okay, and then I will make the conclusion. So I think for a lot of time internally at Uber or externally, people ask what Apache Pinot is, why we need another data storage engine. And to answer these questions, right? So since Apache Pinot is such a new and innovative data product, we really have to see from a higher kind of elevation from like a bigger picture. So I think I want to like use this route where I go from where our larger organization of data at Uber is, and how Pinot fit into this ecosystem, right? And to do that, actually, I borrow slides, right, from a recent published paper by a bunch of guys from Databricks. I really like the way they abstract a lot of interesting aspect of how big this data company operate their own internal data platforms. So in these pictures, right, as you can see, many of today's big company, like here at Uber, right, we do at the bottom collect a lot of informations, right, during our business operations. This information are very diverse. It can be structured data, it can be semi-structured, even with videos and audio information, right? We collect all information, and then these are called company business assets. And then we, as a data org, right, we curate and we put them into a so-called data lake, right? Many of you have heard data lakes today. And actually, this is almost like untreated data. The whole data org's mission is actually try to use some process. Here, I think in this picture, they call it ETL, but that's a very classic term. So the job of this ETL job is basically try to put this data into categories. So extract some metadata information, and then sometimes they will want to provide some so-called index, so that when upper layer applications want to use this data, they can have a very nice categorization and also performant usage of this data. So in this picture, right, they mentioned there are two main usage, right, about this data layer. So basically, they argue for two kind of main use cases. One is called SQL APIs. So people use like SQL statements, trust and tested SQL statement to access the data. And for other like more complex advanced use case, they can use like some more lower layer data frame APIs and so on. So by the way, Uber does not necessarily endorse what Databricks says, but I think this picture reflects a lot of things going in on the ground of data operations, right? So actually in this talk, right, I will focus a lot on this aspect on the left-hand side, which mainly focus on the SQL access of the data. So basically from SQL, now you can basically have a very easy and basically and complete access and of the underlying data collected during your business operation. So interestingly, I mentioned that we don't here actually have a very, I think, black and white distinction between data scientists and BI reports, right? As we can see, so actually many of our data scientists, they also love to use SQL. Yeah, let's just a side note. So now this is a big picture of what my data org is doing. Now in terms of our online analytics platform, actually you can think about this is just an implementation of the previous reference architecture. Now, of course, you want to instantiate, right? You have to flip your head a little bit. So turn to your left. So basically, similarly, we here have this kind of data generation layer. So basically, data flowing into our application, from application to a so-called traditional transactional store. And this is our source of data. So then we have this ETL process, but ETL is actually a very broad term, right? So in our systems, right, we usually use Kafka, which is like today's very popular data in motion solution, which channel this data out. And we also use Hive or this kind of batch system. So both of these like channels can help to put data into Apache Pinot. Right now, they can think about Pinot is kind of federated engine, which basically picks up this data, real-time data, and this batch data from Hive, right? From here, now Apache Pinot do a lot of magic, basically index data, replicate data, so basically make a very scalable distributed solution. From there, we allow our users to use very like simple SQL, easy to use. I would say easy to use SQL engine like Presto or the Pinot SQL engine itself to basically power a lot of applications. Now let's look at a few applications that our customers actually want from us. So basically, this is actually we're talking about some of the concrete user need. And for example, a lot of our product in Uber Eats, for example, is powered by Pinot. In there, they really want to have this need to see, for example, who are the customers who actually remove items from Uber Eats cart during the last 10 minutes. Or some of our machine engineers, they want to monitor the machine learning models performance over time, group by features. And they try to use this monitor to basically add on this kind of machine learning model performance and make some changes on it. And also, for example, recently, there's a case where a product manager at Uber Eats, they really want to show the nearby Eats order from other Uber Eats users in the past hour. Right, so I don't want to read all through all of them, but you can get a sense of the general flavor of this kind of production need out of the data we collected. And interestingly, if you dig a little bit deeper, most of this need can be expressed as some kind of a combination of SQL statements. That's why they come to the Pinot. So I would say, and many of actually these ideas or these needs actually turn into real solutions and products. So for example, right here, right, what you can see is use cases. Well, we have a product called Restaurant Manager. So in this case, the Restaurant Manager basically built a dashboard for each individual restaurant owners so that they can see the kind of revenue or the sales minus of kind of cost they actually did every day. So basically, and then it can categorize by the top sellers or menu items in their store. So, and then basically this can help them to monitor their recent sales through such a very clear layout dashboard. This is Restaurant Manager product. And in Uber Freight, so basically Uber Freight is, you can kind of, it's a marketplace, right? So Uber want to help the drivers to find the load to deliver to the customers. So in this kind of place, it's very important for the users of the platform to understand the market supply and demand, the so-called balance. So basically, for here, we basically help the drivers to see the total number of load they do every day. It kind of, and all kind of statistics about how long they wait to get each load, and what kind of performance, for example, in terms of on-time pickups and deliveries they can get from this freight service. So all these are very important business metrics, which all these drivers, they want to check and to improve their business operations. So, and then this is another product today, actually powered by Apache Pinot. So I believe I went through a few use cases and real product. I believe that's why the reason, right, when we think back why a Pinot have a important space in our data system is that it's kind of a new innovative data engine, which is basically support an intersection or confluence of three important needs from our customers. One is we want a data engine to support low injection latency to begin with, because all those customers, they want real time or up to minutes information in the marketplace or in the marketplace. And at the same time, of course, if you ask customer, they always want low query latency so that they can run their queries interactively. And different from many other simple key value store like Cassandra and so on, the customer really want to do more complex queries. They want to use, for example, features like group by. They can slice and dice the data. So all these actually are the strong suit of like a traditional SQL engines, but those traditional SQL engine like MySQL or like HBase, they sometimes have some problem to support this kind of rich data analytics queries, and or sometimes they just cannot scale out. So this is basically the intersection, right? So we want all three, and Apache Pinot actually provide a nice solution to meet all three needs. All right, so let me basically give you a very high-level summary of what we have today at Uber when we operate Pinot for the last a few years. We roughly have about a few dozen use cases with like 200 and more tables in our servers. So we serve like a few thousand queries per second in production today. And many of these, actually, by the way, these use cases are mission critical because a lot of times the user of Uber app directly access these backend Pinot stores in their transactions with Uber. So that's why we really aim for lower query latency. And also, at the same time, as we mentioned, right, we really want to make sure that if we put out a good data layer, it's also refreshed. So, and all this actually supported by a medium-sized fleet with about hundreds of machines. And importantly, with our internal Uber users, they can do self-service onboarding of their tables and the data set into this platform. So this is a very high-level run to why what Apache Pinot is and where we are at Uber. So a little bit history about Apache Pinot. So basically, it was I think invented by LinkedIn. Thank you for folks at LinkedIn. Basically, they wrote this wonderful piece of software and released it for open source. So when it was designed, so it built itself as a OLAP system, which have this new longer architecture, which basically can stitch together batch and the real-time data source, present a unified view for the users to look at data from a few seconds old to all the way a few seconds, a few years back, right? So I think as an analytical engine, we have seen the Pinot leverage this columnar storage, which is a very popular every tested solution for analytics purpose. Basically, it will help you to compress data and bring out query performance. Finally, it put a SQL interface which support a substantial subset of Pinot of SQLs. So after I think it was released, right now actually you got a pretty wide amount of usage in the industry. We see company from LinkedIn, Microsoft, all the way to Uber and Stripe using Pinot. All right. So I just want to give you a very high level a view of the this Pinot. So essentially, Pinot is basically a distributed data system, a data query engine. So to make the cluster work, Pinot has several components, right? So this picture basically gives you a very high level overview of Pinot cluster. What Pinot cluster looks like. It has its brain. It's called a Pinot controller. So basically, you can think about it's basically control the state and the data distribution of the Pinot service. So you utilize the zookeeper as the I would say the message and the metadata layer. So and when data is coming into Pinot, basically it can have two kinds of Pinot, as I said, support two kinds of data. So one is data from real-time engine or strings like Kafka or other similar streaming system. So basically, Pinot has this real-time server which can ingest and distribute this real-time data into its servers. Similarly, there is a counterpart called offline servers, which basically allow you to use batch compute framework like Spark, like Hive, and so on. So you can basically do a batch computation and push the entire batch of messages and send into Pinot servers. So one thing I actually want to call out for Pinot is that Pinot actually is unite the compute and storage in the same place or Pinot servers. Basically, it's slightly different from other models where there's a kind of decoupling of compute and storage. So So here, the actually compute and the storage happen in the same Pinot servers. So basically, it actually have the advantage of making this computation much faster and efficient. So we can support later. And finally, now you have a broker basically can scatter and gather the data into that Pinot to serve it. All right. So basically, this is a very high level about the components of a Pinot cluster. So let's go on a little bit more about how this distributed system was designed and its main features, right? So as I said, so Pinot allow a broker to basically query different servers. One nice thing about Pinot is that Pinot actually can help you to organize a set of servers into individual isolation units. For example, in this piece, right? So basically, you can have a cluster with like two separate so-called tenants. And then this tenant basically don't share any resource among them, except some like meta information exchange through controller. So that's why for mission critical product, you can actually put them into isolated tenant so that it will not be impacted by other servers from other tenants, basically. So this is about an idea of you can basically in a cluster basically divide the machine into tenants, and each tenant can hold its own tables for customer usage. So in this sense, you can make this Pinot pretty much horizontally scalable. Okay, so as much as you like, and then basically then organize into different tenants. This is actually a fairly good use pattern that we also exploit here at Uber. So next about query execution. So in a query execution, basically there's a broker, as I said. Basically, it can get the query, and we basically can scatter the same query into individual servers. And it's the servers basically execute these queries and return the result back to the broker to merge them together and return back to the user. And actually, one thing I really want to single out here is that even as simple as this contrived example, right? You can see there are some interesting fact about Pinot, where as you can see, each of these colored box, for example, S1 is actually one data unit at Pinot called a data segment. Okay, segment you can think about is roughly a partition of data. So as you can see, there are two colored S1. That means that this data is replicated twice. Okay, the same happened to S2 and S3. What this means is that even a single server in this case goes down, actually the whole data set is still available in another two rest of the servers. So basically, by this way, Pinot use data replication to remove the single point of failure or single server failures, and can continue to serve the queries. So since we are talking about data segment, right? Let's drill a little bit down so that we can understand what's in a data segment. Data segment, as I said, is just a partition of data. So in real-time servers, right? So data flowing from the real-time strings, and the data partition is mostly through time. Basically, you can see there's a time stamp for each data record. And after a few seconds, or maybe a few minutes or a few hours, essentially what you do is basically you make a partition or this cut off this data set and make a segment. So important to Pinot's performance, Pinot use so-called columnar storage, where instead of storing data row by row, it basically group the columns together. You can see, right, in this data set, you have maybe 7 different columns. And what Pinot does is basically store the column page individually, and then similar is that store the column username and so on. Because these columns have data of similar nature, you can exploit a lot of compression technique so that you are able to achieve very good data storage safe. Let's take this example of this page, right? So for example, right now in this page, these are popular singer names. Essentially what Pinot does is basically instead of storing these strings of Justin Bieber and Keisha, basically it turns them into so-called dictionary. Basically map this name into binary or numbers. So now in this case, it can sense basically Justin is value 0 and Keisha is 1. So instead of storing the long strings, now the numbers are stored. And then this way, basically a list of string now can be converted to be a list of integers, which achieve a great amount of saving. And on top of that, you can do even better. So basically, sometimes people want to look up all the pages, which is mentioning Justin Bieber. What you can do is basically so-called inverted index through implementation called bitmap, so that it can have a bitmap which turn on only in the bit where the row indicate or has Justin Bieber as its value. All right. So basically, this is way you can have a very compact and representation of original column. So in our test, right, we find out through this, Pinot achieved 10x compression ratio compared with traditional row stores. Okay. So now I mentioned Pinot as a pretty good distributed data system. And once you have this like big tree, very stable big tree of a distributed system, actually now you can build a lot of very useful index structures on top of the data. So this can help to look up, to speed up the data lookup or SQL queries. And Pinot, I think today is really good at providing a variety of different index. So this table lists the major index type. For example, you have inverted index, you have text index, and so on. So, and then their corresponding usage. So, and then Pinot does a very good job to log individual query features into this index. Right? I have mentioned inverted index just now. I'm not going to repeat it. So, I just want to mention one or two type of other type of index. So, for example, we have this. A lot of people want to sort the data. Pinot actually provides this so-called sorted index, where, for example, in this column A, you can sort these numbers into a list. And then when you store it, right? So basically, now you can store the sorted index and the range of document ID starting and end, which contain this column A value of 1 to 3. And then you can do the next 4 to 5 and so on. So when you look at this representation of original table, it actually achieves a few purposes. One is data is much more compressed, as I said, right? Instead of setting each individual rows, now you have a number with its range. Second, if you want to do lookup, for example, if lookup data point column value equal to 4 to 5, now you actually can do a quick binary search of the columns. And at the same time, you can even do the reverse lookup, so-called if value, because this document ID is also sorted, right? You can exploit the same range search mechanism as well. So this is basically, this is a very, really strong feature if you can sort your data. So, but of course, you need to make sure that understand, because there's only one column that can be sorted. Okay, so this is about sorted index. And now let's go to the next very interesting index, which is called star tree index. Actually, this is where actually the company gets its name. So a star tree index is actually used to answer this type of questions where you want to get aggregation, like sum of some columns. For example, in this query, you want to get the sum of impression grouped by countries. So normally in a table without index, what you have to do is you have to scan the entire table and to do the sum during the scanning, which is very, very costly. So Pinot provides this called star tree index. Basically, essentially, the idea is it trade off some space for a query time performance. So it prepares the aggregation results beforehand, right, based on the query need. And then in this, for example, it can first do a grouping of the countries with their impression sums and store in a so-called star tree index. And then you will be able to answer it through lookup during query time. So of course, the thing is that you need to make sure that Pinot does a very nice trick of basically organize this sum, okay, and to make sure that you do not blow up your storage, because in the worst case, you have so many different combinations of different values of columns. So Pinot will adaptively and just aggregate the rows in it and with the storage in consideration. And the running time basically can look up this summer table. So this is called star tree index. And for more detail, you can go to this link and to see how you can configure your table to enjoy the star tree index. So by now, I think I mentioned about index. I mentioned about a Pinot cluster. So this ends the introduction of Pinot. And after right now, I'm going to mention a little bit about how at Uber we basically utilize this Pinot. And there are actually some things that actually I want to mention as something that I see as a unique feature of Pinot, or it's, I would say, to be frank, its limitation. One of the things that we know that I didn't mention is that Pinot actually cannot provide general join of tables. So basically in traditional SQL, right? So you can join two tables and do the selection and so on. But actually Pinot today actually does not provide direct support for join at query time. So then how we can satisfy our user need when I really want to join two tables together? Actually, we here at Uber actually employ such a technique called injection time join. By that, I mean we use solutions like Apache Flink, which allow you to join multiple, for example, Kafka topic with other store together. Now you can have a single output Kafka topic, for example, and then can be ingested by Pinot. So, and then you can roughly think about this is like database denormalization, where you combine multiple tables data combine them into one. All right. And finally, so this will go around the problem of doing join at the query time. And it turns out actually many of customers, we talk to them, they are actually okay with this solution. And this is on the real-time side. In offline side, because you have similar solution, you can use Hive to do the join of other data sources together, so they can piece into one single table. So this is about how you can like do use injection time join to basically merge multiple tables together. So another thing about Pinot is basically when it was designed, it followed this very classic model of a pen owning model, where actually you can literally you cannot modify the data. The previous load you ingest into Pinot, and in a lot of our applications actually lacks need to do data change. For example, for the Uber Eats order, right? An order state may change from on delivery to delivered or and then closed, for example. So basically, how can you model this mutable data in Pinot? So earlier, Pinot has to use a lot of basic ad hoc solutions, and right now, actually, in our data stack, we started to support a new feature called Pinot Upsert. Basically, Upsert allow you to do update and insert of a new record into Pinot store, and it's available after 0.6. So with Upsert, now you can use organize your data and then basically identify record using a primary key and modify the data state. This is a really nice feature, so that a lot of our users are using it. And for more detail, I'm not going to deal too much about this in this talk. You can check out the link from this talk or search by Pinot Upsert. Okay, so this is a nice addition. So next thing about query. So I mentioned, right, actually today our user actually can query Pinot through multiple query engines. One of them is, of course, Pinot SQL itself. But many of our users, they also want to use their own data engine like Presto. So Presto is a very popular distributed SQL engine for big data. So it actually is a federated query engine, which you can plug in multiple different sources of data stores, like Hive, Cassandra, and so on. So basically, naturally, we want to also become a pluggable store for Presto. The reason is that Presto, for many of our users, it supports pretty flexible query syntax. You can write a lot of UDF, which is basically support natively through Presto. And in this picture, Pinot actually will enjoying, we will contribute to this stack by providing much better query latency. Because as you can see, compared with other data sources, Pinot provides very, very strong index support. And then also Pinot can help you to bring the data freshness down to a few seconds. And in this, you can see we can enjoy the best of two worlds, where you have one side of Presto, you can have very rich query syntax, and at the same time, on top of Pinot, which provide you a really good and scalable storage solution. So, of course, the things are not as simple as you just put together two systems, they will work together magically. There's a lot of like engineering to be done to make integration work. Actually, we went through a few iterations, right? So this picture actually explains how we actually make a Presto Pinot connector, so-called connector, so that you can literally do intelligently write of Pinot queries, of Presto queries into the engine, into a Pinot statement, which can enjoy on the processing power of Pinot. So in this picture, so we use a technique called aggregation push down. The idea is that you really don't want to leave all these aggregations for Pinot, for Presto to process, because that will be very slow, and then you need to put a lot of data out of Pinot. So instead, what you try to do is you basically extract most of the query aggregation feature from your Presto query, and then push most of the computation down to Pinot, which is a much better storage engine, and let Pinot to handle all those aggregation for you and return the results. And the Presto aggregation just need to do very minimum amount of merge work. So this is the so-called aggregation push down idea. So today, I think a majority of our users are using Pinot through this Presto gateway. Now let's talk a little bit about how we can make production excellence on Pinot at Uber. So as you can see, right, today, I mentioned there are hundreds of millions of queries that flow through our Pinot cluster. And many of them are business critical. They need to have very high SLAs. So, and the question naturally arises how we can protect this service through these query, these hundreds of millions of queries. And it turns out actually we find out one of the most disruptive force or factors on the platform is the user queries themselves, because if you don't treat them carefully, many of these queries are very expensive to process, and they can basically slow down the server performance and sometimes just bring down the entire server. So even with all those techniques like tenant isolation and so on, you still need to make sure that the servers in the tenant are basically in good status. So the key here is for us to get good performance and optimize for the queries. And of course, this is about service protection, like any internet service companies. Another thing is, we want to think about, we really want to conserve resource so that basically we can put as many tables into a few servers as possible to increase server utilization and save the company money. So to this end, it's really important for us to find out all those bad performing queries out of these hundreds of millions. So to this, we really take this philosophy where we think user query are important piece of data. We have hundreds of millions of every day. You need to use some like good software tools to analyze these queries. And it turns out the best tools, right, we have at hand can be Pinot itself, right? So because Pinot itself is a very powerful analytics engine, which can aggregate these queries and help us to identify those queries which have performance issues. So this is what we call the query and index management. So to build this kind of analysis pipeline, what we did is we start with so-called Pinot query stats log. So actually today, Pinot's broker emit runtime information about every single queries it runs. Basically, in these stats, right, it has the query itself and other vital statistics like number of documents scanned, and of course time spent, and server status, or number of segments scanned. All this very detailed information about a query at runtime. So we actually need some derived information I will talk about later. So with this source data, right, about data statistics, we actually make a Kafka string out of this query stats and ingest them back into Pinot itself. So now you have a very structured table. Now this will become our source of our decision. We then build such a so-called optimization engine, which queries query stats table, which help understand what are the bottleneck of the queries, what are the particular group of query have performance issue. Then we can use them to make decisions. So this decision can be either we add and remove index, or we can even sometimes block expensive crucial queries. Now let's look in more detail about how we can do these kind of decisions. All this again is based on the query data themselves. So in these slides, right, in the bottom half of it, you can see actual real Pinot query stats entry. So basically, it record the query itself and all those kind of runtime statistics. So some of the very important factors that we utilize is so-called scanning numbers. So in an intuitive sense, right, if we find out a particular query, need to scan a lot of documents, but in the end, there's only 1 or 2 documents in the results. That probably means that this table is not tuned to have the right index to answer this filtering or scanning condition. So for example, it doesn't index the user ID, for example, right? So by the way, by default, Pinot, because of storage reason, does not provide inverted index for the columns. So that's why we need to discover the user need, and then based on that, so you provide the right index, right? So this is about how you can use these simple rules about high scan versus result ratio to discover missing index. There are similar rules. For example, if the scan versus result ratio is really low already, close to 1, but you still need to scan a lot of documents. That actually probably means the user query themselves are not very selective, or sometimes there is some hotspot in the data set inherently. So for example, in our actually real operations, we actually find out in one case, a user actually mistakenly put a lot of data with null values into a row which has value none. Okay, so basically, we find out whenever they run a query and they somehow select this condition of null, and then they have to scan millions of documents. So, and then this definitely bring out a lot of performance issue. And then actually, when we bring this performance issue to our back to customer, they discover actually in their program stack, they have some bugs, basically create these hotspots. And then once they remove the hotspot, the performance actually improved by more than 20 times, right? So all this is actually a lot of optimization based on user queries. And then from queries, we can actually understand user needs. This has become a very, very nice cycle of improvement. So that's why I think from our experience, it's really important to understand user need, and actually sometimes you will know better than your customers about themselves by looking at the queries, because query don't lie. Okay, so actually I don't want to mention too much further, but okay, you can also do a lot of interesting aggregation and about these customer queries. We find out that, for example, although we have hundreds of millions of queries, but if you really want to see the underlying patterns or the structure of the query, only hundreds of them. This is actually a good indicator. The usage of Pinot by our customers is they really want to use Apache Pinot as a very high throughput application engine or server, so that they can get very a lot of high volume traffic adjust through this kind of rich OLAP engine. Okay, so this is about how we can do query and index management, starting from the query performance itself. So finally, I also want to mention some like special needs from Uber business operation and how we resolve them. So one of our needs, as we can see, Uber is a operation company, a business. Basically, we need to make sure that our business work 7/24 in all continents of the world, right? So on that, really important for us is the real-time injection can be flow like water to our product, and to this end, a lot of we make some adjustment to Pinot injection, for example. So early on, Pinot when you do its real-time injection, it rely on a so-called deep store to make sure that data are backup, and when a server down, it has something to recover. But the problem is that now you create a dependency of Pinot on its this deep store. So sometimes these deep store are third-party provided solution. When it's down, that means Pinot will have real-time injection got disrupted. So this is not allowed in our platform. To solve that problem, so about to achieve continuous real-time injection, what we did is we basically modify the real-time injection protocol so that when a deep store is down, Pinot servers can actually, instead of rely on that external data store, can discover the segment from other peer servers, which is already present because Pinot does replication, data replication. So this will help Pinot to use peer segment download to continue injection until the deep store is back. So, and this is actually a very nice feature we have been here used for Uber for quite a while. And actually, we do find it help us to address when our deep store like HFS is down. So in order to use this feature, I provide a link. It's also available in Apache Pinot official doc. All right. So actually, this is almost the end. Okay. So I really want to summarize this talk by let's go back to this original picture where you have this data lake architecture where user really now want to have a maximum usage of the vital business data injected in the data lake, and how actually Pinot fit in this structure, which provide a very strong SQL support where it's like distributed data systems, and also it's clever and diverse use of its index structure. And I would say data lake is a really important problem like today's engineers need to resolve. And I think we in this talk we mentioned how data Pinot actually fit into this picture. Okay, I will end this talk by going back to this picture and help you. Hopefully, you will see from my talk how this Pinot is able to help to achieve our business need. Okay, that's the end of my talk. Thank you. So I also want to thank the entire Apache Pinot team at Uber, basically operate the entire ecosystem in the past few years. And we really got a lot of support on the open source community. And as you can see, a nice thing is about Pinot is basically, you can actually, this is an evolving open source system. And a lot of time we got help, and sometimes we contribute back to the community with features and so on. So this is already an open community. And I think if you have time, please check out the GitHub page. And also take a look of the, if you have issues, there is a Slack channel to support it. All right. I will hand back to Karin for questions.
That was awesome, Ting. If anybody has any questions, please feel free to ask now. There is a slight delay, so we can give people a couple minutes. There are a couple questions that came in that a little bit earlier. And PS, Uber Data is hiring, so the data team, so if you liked it. Okay, so we do have some questions. I'm going to start at the top. I think some of these might have been already addressed, but Mahendrakar asked, "What is the role of Presto?"
Oh, I see. So I think please, I think I mentioned some of them in the slide. So the Presto is actually a very popular, I would say, query gateway, and our users already use it at Uber. So they actually provide features like rich UDF, user-defined functions, and some of these are not today supported by Apache Pinot. So that's why you really want to complement this very good storage engine with Presto, which is a well-received query layer. So that's why I mentioned that we actually today mainly support Presto as our query layer. Hopefully that's address your question.
I mean, that sounds pretty thorough. I think it doesn't. If it doesn't, Mahendrakar, you can elaborate on the question. Yuri asked how to handle data deletion.
Data deletion. I think there are several sub problems to this question. I think so. For example, I mentioned Pinot upsert, which is support. Upsert actually means update and delete. Or upsert or insert. I'm sorry. Basically, when you do insert today, what you can do is, for example, using a so-called soft delete technique. Basically, you put a so-called flag indicating the data is deleted, or using the technique is also called tombstone idea. So basically, this is data is deleted. That will couple with upsert will help you to resolve the delete problem. And this is on the real-time side, right? So if you really want to use the data Pinot offline table only, you can actually do a wholesale delete by recompute the entire state of your data store and push to Pinot. And this is another solution. So yeah, and then depends on again what you need. If you can model your data as real time, use upsert. If you can use your data model it as an offline data store entirely, and then you can use the entire snapshot computation mechanism.
Nice. That's very elaborate. I'm like learning so much. Okay. Xiaobing says, thanks for sharing. Hey, Ting, thanks for sharing. Could you help shed some light on extracting query signatures from those raw query logs?
Okay. I see. So by the way, there's some paper on this, not written by Uber, but the basic idea is the signature really depends on your business need. For us, what we really want to get from the signature is we want to categorize the queries into millions of these queries into a few of them. We can help to understand their need, for example. So that's why all these signatures have this flavor. You want to take away the noise. This noise in our case, for example, can be, for example, in your SQL queries, you have some constant in a Boolean condition you really don't care about. For example, you in the expression a larger than 5, what you really care is you care about a and larger. I don't care about this constant value 5, for example, right? So that's why I remember in my talk, I mentioned we use a particular signature called filtering column. We just need to look at the select conditions of a SQL query and look at the columns used in these select conditions. This set become a signature, because this will help us to derive the necessary index. So this is kind of index. So, but I wouldn't say that this is the only kind of signature, right? So depending on needs, for example, you also want to compute the group by column and so on. So this is actually a kind of pretty flexible here. But to us, this can help us to like compress the millions of queries per day into maybe a few hundred manageable signature type, and then help us to understand for each individual group their query performance statistics. Hopefully give you some idea we have.
That's awesome. If anybody else has any other questions, please ask now. If you're watching this on demand, like I said, you can go to the Pinot Slack. And also, so Xiaobing said, awesome, thanks for the explanation. Mahendrakar said, thank you, Ting. Mayank said, great talk, Ting. Always awesome to see you talk. Rahit, great talk, Ting. Very exciting to see the use of Pinot at Uber.
Yeah, no problem. Yeah.
It's awesome. Cool. So, I mean, we can give another minute to see if there's anybody else who has any other questions. If not, we can wrap up. But thanks for taking the time, Ting. This is awesome.
No problem. Yeah.
Really good stuff. It's really nice that you guys are like so open of sharing all the ins and outs of what you're working on and how you're doing it and helping other people work through these complex data problems.
Yeah. Yeah, I think we were also sharing the recording, right? So
yes,
I got a message saying that they cannot attend, but they want to see the recording.
Yep, it's going to be available on the same YouTube link as it was on the Meetup group. So it's going to be up immediately. We are going to add little segments to break it down so people can jump around if they want to see specific parts.
Okay.
But yeah, it's good. All right, awesome. Well, thank you everyone for joining. Thank you so much, Ting, for presenting.
No problem. My pleasure.
And please don't forget to subscribe, like, comment, and feel free to give your feedback to Ting. If you're watching on demand, you can reach him on the Apache Pinot Slack. Yeah, and that's it. That wraps it up.
Bye, and good luck.
Thank you. Bye, y'all.
Bye.